This is the first video tutorial for Lab 3. Lab 3 is going to be looking at raster data services and how we derive secondary services from a base data digital elevation model. And this elevation model can be downloaded from Blackboard under Lab 3 data. It's going to be the sole piece of data we're going to use for this lab. From this digital elevation model we are going to get 3 new surfaces. We're going to get an aspect surface. An aspect surface records the direction of all the space in a digital elevation model. So whether it's facing north, south, east or west, it will return a value between 0 and 360 degrees, and depending on what direction that part of the landscape is facing. The second surface we will create will be a hillshade surface. A hillshade surface will record the amount of shade which falls on every part of the landscape, depending on what is blocking the sun touching it. And finally then we will create a slope map. A slope map will record the slope in degrees between 0 and 90 degrees of a landscape. First thing we're going to do is to add the data which we'll have just downloaded from our file. We do that as always by clicking the Add button. We'll then need to, of course, navigate to where we've downloaded our data. This can be done using this button here, which we can click. And we're then given the option to connect to any folder we want. You will browse to where you have stored your data, which should be as part of your general data folder which relates to this course. So for me, I have this data stored locally on my desktop. I'm just going to click OK. I'm then going to go into where I stored this data and I'm going to add it. Okay, again this gives us the warning about missing spatial reference. Just ignore that for the time being. And then it will add this digital elevation model. Now it might ask you whether or not you want to create pyramids before adding it. Creating pyramids is a technique the GIS uses so that every time you load the data again it loads up quicker. It is something worth doing, so just click yes. It shouldn't take too long. Okay, so this is our elevation model, our digital elevation model, and it has a 50-meter resolution. A 50-meter resolution of a digital elevation model or a raster surface means that each cell represents 50 by 50 meters. So we can use all the same tools to actually navigate and look at this data. Let's zoom into the area we're familiar with. Here's the area of the Boyne. Bend in the Boyne, zoom in further, and we can see as we get closer that the area becomes more and more pixelated. Now each one of these pixels represents a distance of 50 meters. We can find that by clicking on our measuring tool, and we can see up here that the value is 50 meters. Okay. Let's zoom back out again to the full extent. So we have a digital elevation model which covers most of Meath and parts of other counties as well. In this elevation model, of course, the symbology chosen is that areas in white represents higher ground and areas in black represent lower ground. Now we can change that symbology the same way we change symbology with vector data, by right clicking on our file in the layers tree, clicking on properties, and once properties is open we can see that we're given these options between classified and stretched. Now we're going to keep this as stretched. If we were to click on classified, what it would do is it would divide up the landscape into a series of bins, so dividing up between values of 0 and 10 meters, 10 and 20 meters, 20 and 30 meters, and so on. With this data set, the GIS might not actually be able to do that given the large numbers of data, so we're just going to stick with stretched data here. We can see here that the highest data we have is 584 meters, and the lowest data we have is a low point of -8 meters. Now we can, if we want to, change the color involved with the GIS. So if we don't like the black and white, we can change that to something really anything we want. Let's take a look at what some of our options here are. Let's just select this here. And click apply. Click OK. And you can see that we've changed just the basic colors of that, so that areas in blue are very high and areas in red are very low. And that's not a particularly nice data set, or nice symbology, so let's turn it back to something we're just a bit more familiar with. There we go. Sorry, it's very slow tonight. Now we can of course also add something called a hillshade effect to this, which just gives us a bit of a more accurate portrayal of the topography of the landscape. Let's do that. Let's just click this button here, and the Z factor here will leave it 1, but if we wanted to add an artificial exaggeration to the landscape, so make it look more mountainous, we could increase that Z ratio to 1.5 or 2. Let's click apply, and then OK, and we can see that our landscape has gone back to this black and white symbology, and that the shading data is on there as well.